Hello everyone, welcome back to my channel after a long time. Today I've come again with a new chapter. But before starting with the definitions and all, let's have a concept of an important topic of this chapter, and which is Cartesian product. Now again, before coming to the definition, let us start with an example. Let us suppose that I have a set A. And what is that set A? It is a set of different colored pens. Suppose I am taking two types of pen. One is a red pen and the other one is a green pen. Whereas I take another set B, which is set of different colored caps of the pens. Of the pens means of that of set A pens. Let us take any three colors of the caps. Suppose if I take a red cap, if I am taking a green cap, and suppose I am taking a black cap. Now why did I come to this example? Just to find out that how many combinations can be made between the pens, different colored pens and the different colored caps of the pens. How many combinations can be made? Now for one pen at a time only one cap can be used. You can't use more than one cap. So likewise, what will be the combination in this case? Now the combination will come as like for the red for this black pen for this red pen, red cap, green cap as well as black cap can be used. Whereas for this green pen, red cap, green cap as well as black cap can be used. Now let's write the combinations. For RP, I can write RP comma RC when red pen and red cap are combined. That we can make. Again we can combine red pen and green cap. Again we can make red pen and black cap as one combination. So over with the red colored pen. Now start with the green colored pen, that is GP comma RC, GP comma GC and GP comma BC. Okay, so now if all the combinations we write it within this second bracket, so what is the thing we got? We got all the possible combinations of the different colored pens. Like here we took two different colored pens and the different colored caps of pens. So all these combinations are together called Cartesian product. So what will be the Cartesian product? What will be then the Cartesian product? That's equals to A cross B. We spell it as A cross B. Why A and B? Because we took the sets as A and B. Now question might arise in your minds that why not B cross A? It could be B cross A also. But it will not be B cross A. Why? Because see, when I am writing A cross B, you can easily understand that A is in the first place, B is in the second place. Now when you clearly observe the combinations which we have made, first place, what is there? The pens are there. All the pens are there in the first place. And whereas in the second place, we have only the caps. We have only the caps, and caps are all belongs to set B. That's why you have to write A cross B and not B cross A. B cross A, the moment you write B cross A, it means that all will be getting interchange in the positions. Like what am I saying? The combinations will be RC comma RP for this one. It will be GC comma RP. It should be BC comma RP. All the combinations will be interchanging their positions if it is B cross A. So the order of Cartesian product matters a lot, and one thing you can then understand that A cross B is not equal to B cross A in the concept of Cartesian product. Now, so what can we conclude from here? That if any two non-empty sets, non-empty means sets can never be empty when we are giving the concept of this Cartesian product. There has to be some elements in each of the sets. So given two non-empty sets A and B, the Cartesian product A cross B, what is it then? Is the set of all ordered pairs whose first component is a member of A, which just now I said member of A, and second component is a member of B, which is a very important note which you have to note it down in your copies. It's very important. That's why we have come to the conclusion that whatever is A cross B, that is never equal to B cross A when you come to the concept of Cartesian product. Suppose it's given that A is again a set with elements 1, 2 and B is a set of elements, 3 elements, suppose x, y, z. So you can write this in matrix form as well. Suppose A has 2 elements 1, 2, whereas B you can find out as x, y and z. These are all elements of B. So what can be the possible combinations of these elements? With 1, x can be combined, with 1, y can be combined, with 1, z can be combined. So when you combine 1 with x, it has to be written in this place. When you combine x 1 with y, it's written as 1, y. When you combine 1 and z, it is written as 1, z. When you combine 2 with x, it can be written as 2, x. Likewise, 2, y and likewise 2, z, which is exactly A cross B. So no matter whatever might be the order of the sets, like no matter how many elements are there in either of the sets, you can easily find out that how many combinations can be made out of those two sets. Now before going to the properties, let's have a concrete definition of Cartesian product. So if I take, suppose again, A and B as two sets, let A and B be any two sets, then the Cartesian product A cross B is the set of all ordered pairs. This part is very important. Ordered pairs whose first coordinate is an element of A and second coordinate is an element of B. That is, so how can it be represented? A cross B equals to X comma Y such that X always has to belong to set A as because A cross B, and Y has to belong to B because it's A cross B. Now we start with the properties of Cartesian product. The first property, which already I have mentioned earlier, that Cartesian product is non-commutative. That is what we can say, that if I take two sets, then A cross B will never be equal to B cross A. You can take again any two example like 1 comma 2 and B. Suppose if you take as 3 comma 4 and you find out the elements of A cross B and B cross A, of course you will find them as different. You can find it out and see. This will be what? 1 comma 3, 1 comma 4, then 2 comma 3, then 2 comma 4. And what will be B cross A? It will be, then first the elements of B will come first and then the elements of A will come. So this will be 3 comma 1, 3 comma 2, 4 comma 1, 4 comma 2. So clearly you can understand that A cross B, it's not getting equal to B cross A. This is the first and very important property. So what we can conclude, that if A is not equals to B, then what we will have? A cross B is not equal to B cross A. As the sets itself are different, having different elements, so that's why A cross B, this combination will never be equal to the combinations of B cross A. If the sets were equal, then it would be the same case. But as because A and B individually holds different elements, so therefore combinations will also be not equal, and hence we can say that they are non-commutative. Next, coming to the next and one more very important this property is that A cross B is equal to B cross A only if A equals to B, just the reverse of the previous property. In the previous property we concluded that as because A was not equals to B, here what we did, as because A was not equals to B, that's why A cross B was never equal to B cross A. But in this property, it's just the reverse of the first property, where A cross B is equals to B cross A if A equals to B. So how we can prove? Let A cross B be equals to B cross A. Then what we have, if both the are if A cross B is equal to B cross A, then what we can say, all the elements of A will be contained in the elements of B, as well as all the elements of B will be contained in the elements of A, as because Cartesian products are equal. So of course it's quite valid that all the combinations will also be equal. Combinations are equal means the elements of both the individual sets must be equal. only then the combinations can be equal, right? So from there we can say that A is contained in B, as well as B is contained in A. So from this two, what it will follow? It will follow that A equals to B. Very important, these two are, the first one is non-commutative, A cross B not equal to B cross A. If Cartesian products are not equal, it will obviously imply that the individual sets have different elements. And if the Cartesian products are equal, it will imply that the individual sets have same elements. Now coming to the next property, property number 3, which is this cardinality of Cartesian product. Cardinality of Cartesian product. And you know what is cardinality is in the chapter sets. We have learned that how many elements are there, number of elements in a set is all about cardinality. So in case of this Cartesian product, cardinality is defined as number of elements in A cross B. Number of elements in A cross B, that means in the final combination set, and it is equal to the product of, in A cross B is equal to the product of cardinality of both sets. That is what it is saying, that A cross B cardinality is equals to cardinality of A cross cardinality of B. If you take, suppose A is having two elements 1, 2, and B is having two elements 3, 4, what is A cross B? A cross B, just now we did many a times this combination, 1, 3, 1, 4, 2, 3, 2, 4. So what is this cardinality of A cross B? That means how many elements are there? 4 elements are there. And what is cardinality of A and cardinality of B multiplication? How many elements are there in individual set A? 2. How many are there in individual set B? 2. So 2 multiply 2 is again 4. So hence you can conclude that cardinality of this Cartesian product is that the number of elements in A cross B is equal to product of cardinality of both the sets. So this one was property number 3. Property number 4 is A cross any infinite set. Infinite set is equal to infinite set, where A is non-empty set. What does it mean? Again, suppose if you are taking two elements as 1, 3, and B you are taking an infinite set like 2, 4, 6, 8, 10, comma, dot, 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 dot. It's an infinite set. Now this also Cartesian product we can find out, it's possible, but the thing is that it will be an infinite set. Why? Because if you try to find out the combinations, it will be 1, 2, it will be 1, 4, it will be 1, 6, 1, 8, 1, 10, and then dot, 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 dot. After that it will go on infinite ways. And again if you take the combinations of 2, 3, 2, 3 comma 4 again dot, it will go on. You don't know where it will end. That's why the resultant set which you get, that will be obviously an infinite set. Okay, so therefore A cross any infinite set will be an infinite set where A is a non-empty set. Coming to the next property, property number 5, A cross any phi, that's always equals to phi. Phi means it's a null set. So any null set, if you find the cross product of, if you find the Cartesian product with any non-empty set, the result will always be a null set. Again, the one last property is that if you are taking the if you're taking any set capital A, and if you are finding out the triple product of it, and suppose, so what will be the definition? It will be A comma B comma C such that A comma B comma C belongs to the set A, where ABC is called ordered triplet. When you take 3 elements at a time, is called ordered triplet. We will do few sums on this ordered triplets also after we finish off with the properties. And so regarding the cardinality, I have given you of 2 sets. There are of 3 sets also. So let's recap once the cardinality laws. The first one we did was n of. I wrote that way, A cross B, that can also be written as n of, because cardinality means number of, and short form of number is n. We can write that's equal to n of A multiply n of B, which we already wrote. This is for 2 sets. In case there are 3 sets, A cross B cross C, then it will be n of A cross n of B cross n of